So assume on the contrary, there's not an infinite number of primes. If there's not an infinite number of primes, I can actually list them all. There's a first one and there's a last one. There might be a billion infinite number of finite number of primes, but I can actually list them all. So then I don't think I wrote this for you guys initially, but I can list them like this. P1, P2, dot, Pn. So there's a first one and there's a last one. These are all the primes. Good. Okay, so I'm going to do some machinations with this. First of all, if there's a finite number of them, I can just multiply them all. That's called the product. So my first evaluations, when I first started teaching, they said I taught too fast. So I thought I'm just going to write everything I say. So then all that happened is I ended up writing as fast as I talk. So I'm watching Joshua's pen to see when I need to stop and I need to pause. And it's okay. Just say, hey, Dr. T, stop. Because I'm like Forrest Gump. I'll just keep running. Good? Okay. All right, so I'm going to take that list. There might be a billion of them, so there could be a lot, but there's a finite number, so I can multiply them together. Let n be the product of all those primes. Another thing I did, which it's good for you to see that, I didn't write all the details down. When we write proofs, they should be so effortless to read that no one can see the sweat that was involved in putting that together. So because I didn't write things down, you were confused, which means it was a badly written proof. All right, so the D that I have on your fill in the blank, I called it P sub I because I had something else in my mind. I was going to do this little lemma. I'm going to just not do that. So the D is a PI. So one of these guys up here, and I know just one prime in that list divides n. Call it P sub I. I remember somebody in foundations, not last time, but the time before that, telling me when I asked her what does divides mean, she's like, it's obvious what something means to divide something else. But in math, we have to write a definition. And so what it means for something to divide something else without using, we are not allowed to use division because we're working on the integers. So some of you actually put division. You can't do that here, just like you can't divide matrices. Can't do that. So go ahead. Oh, so yeah, the reason why that's true is remember when you were little and they made you do a prime factorization. So they gave you like 27, they just say break that up into primes. So the reason you could do that is that every single integer can be written as the product of primes. So it's got to be one of those primes that divides this guy. Right? So if I give me a number, you just give me a number. Make it easy. 27. 3 divides 27. So I got one prime divides 27, right? 31, that's prime. Well, 31 that divides it now, so I'm done with that one. Right, so every single natural number has a prime that divides it, at least one,
Yes, yeah.
right? So
And what do you mean the next number higher is n plus one?
the next number higher than n is n plus one, right? Just consecutive.
Yeah.
And I know a prime in that list divides this n plus one.
So if n is like 20, n is 30. N plus one would be 31.
Yes.
31 is not in that list.
Well, this is not going to be true, right?
Okay,
Right, because I'm gonna come up with a contradiction at the end,
okay,
right? So. But what I'm gonna come up with is that when you have consecutive numbers, they cannot have a common factor. 30 and 31 don't have a common factor. I'm gonna show you that with this. If I assume the opposite of what I'm trying to prove, I'm gonna come up with a sentence that doesn't make sense,
oh,
right? So the opposite must have been true,
oh, sure.
right? Does it make sense?
So,
Oh, then I'm still looking confused. So the next number higher is n plus one, that makes sense. And a prime divides it, so that last part's not true, so no prime divides n plus one.
A prime divides it. One of the primes in that list must divide n plus one because. So that's called the fundamental theorem of arithmetic, that you can take any number and then break it down into primes. You know, when they first start teaching you how to break up radicals, like you have square root of 27, and they teach you, like, a good teacher would have told you, like, take 3 times 3 times 3, you got 2 3s under the radical, you pull one out, right? Prime factorization is like the best thing in the world, actually.
So when we're saying that list divides, do we really mean divide that plus one, or we still just?
Both, right? A P1, PI divides n, and a PI also divides n plus one. So this is notation. So I asked you some notation questions. I asked you what d divides n means. It means that this symbol means divides. It's not a fraction. It means n equals pi. Yes, I did use this. I was gonna use S again, but you never know what my brain does. That's a definition of divides, right? 3 divides 6 means that 6 is 3 times 2. 4 divides 8 means that, let me pick something that's not 2. 3 divides 9 means that 9 is 3 times 3. So I can always find this factor. That's what it means to divide. So sometimes, like, I'm sure you guys get this too. Somebody sends somebody over to you for help in math. My neighbor's kid came over for help in division. Like, I'm not sure I can even explain that. Like, I don't do that kind of math, but this is how you teach it, actually. You teach division by using factors. Well, I told my neighbor, hey, this is, like, you know, I don't really teach long division. But then she came and she's like, let's just help her. Like, okay, messed her up a little bit, screwed with her mind, and then sent her back. When you have divides, it means this.
So I'm still confused between 7 and 8. If n plus 1, let's say, is 31.
Right,
And that prime that divides n plus 1 is 30.
it's 31.
So then the next question is, why does that same prime have to divide n?
Well, it's not actually true, right? I'm going to show you why this is not true. We're getting there. So don't put a concrete number on it yet.
Okay, so
Right.
I just want to understand. I wrote it doesn't. Not true.
So does this logic on the board make sense? That if I have any number I know it's got a prime that divides it. Do you believe that? Okay, that same prime has to divide n because n is the product of all primes. Do you believe that? Okay, so I'm gonna come up with a contradiction in a second. You're going to the numbers and going, this can't be true. It's not true. Right, hang on 1 second. Pi also divides n plus 1 as stated earlier. There is a prime that divides n plus 1. The name of that theorem that you used when you were a kid is called fundamental theorem of arithmetic. You're about to see the contradiction. Some t that's an integer. That means t is an integer. Good. Now I'm just going to do some high school commutative algebra. I told you that first day, this is the easiest question you're going to get all semester. N plus 1 minus n is 1. And by substitution, dt minus ds equals 1. And by high school algebra distributive law, I can factor out the d. That means that d is t minus s equals 1. And now we come up with a problem because when I use d's, like I should use p's. Here I go. So it's the pi, right? Pi times t is n plus 1. Pi times s is n. So that's true. I can factor out the pi. And now I have the product of two things is equal to 1. And those two things must be an integer. Because those two things are integers, that's a solution. And pi equals minus 1 and t minus s equals minus 1 is a solution. Those are the only two solutions that are possible to that equation. Agree? That's like the only way you're only working with integers. Because you're only working with integers, the only way you can get a product of integers to multiply up to be 1 is that if both of them are 1 or both of them are minus 1. But now we have a problem because that tells you that pi is either 1 or minus 1. And that can't happen. Then it won't be a prime number. Prime number 1 is not a prime number.
Brief. So at what pi is an integer because it's prime is always an integer.
Yes.
And then because t and s are
Integers.
integers that factor, they have to be an integer. That's
Right.
a Factor.
The difference of integers are integers. Right? You can't. That's why integers are so nice for elementary school. You don't like add up two integers and end up with square root of 2. That's never going to happen, right? So, I think life would be very hard for elementary school kids if it did. So it's closed. We call it closed. How many of you took linear algebra or are taking linear algebra? So they'll talk about being closed under addition and closed under scalar multiplication. If you just work on the integers, it's closed under addition. And if the scalars are just integers, it's closed under scalar multiplication. That's why it's such a beautiful space to work in for elementary school kids. All right, good. So now I write my final statement. Prime numbers can't be 1 or -1. So the issue that you were coming up with that, hey, 31 and 30 don't have a common divisor, that's impossible. You're already seeing it for numbers. That's where I'm headed to with symbols. Symbolically, like you had it for one example, 31. But how do you know it's true for every example? This is a symbolic example that shows it's never true. Like you can never get that to happen. So my assumption that there was a finite number of primes was false. And the opposite is true. This type of proof is called a proof by contradiction. It can only be used when you have two possibilities. There is or there isn't. So there is either an infinite number or there isn't. So you assume the opposite because it's easier to work with that. I have some algebra I can do, and then I come up with a grievous statement along the way, like the prime number has to be 1 or -1. That's the problem, like here. Ask me questions. All of it made sense?
Question, can you explain why it has to equal the items? Want to make a point? Like, why do you say like offer the possibility that 1/2 minus s?
You can't divide integers. It's not closed under division. Right? The integers, you can't divide them. 2 divided by 3 is not an integer. You're working on the world of integers. That's a good question. I've seen this before. That's why I know to do that, if you have to do one yourself. So if you get your PhD in math, not data science, not OR, you get it in math, then you will have to probably, if you go to a normal math program, RPI is not a normal math program, NJIT is not a normal math program. But if you go to a normal math program, you have to write your own theorems. You start with conjectures that you think are true, you write your own theorem, and then you prove that theorem. And I guess your advisor can help you, but my advisor told me he gave me a good problem. That was his job. Now it's on me. Yeah, that is what mathematicians do. It'd be really great if you guys could go to the joint math meetings in January, if there's a way to get you guys to go there, because then you'll get to see that environment of mathematicians congregating to do math. You'll see those lectures that theorems and proofs are what mathematicians do. That's what makes us different than another discipline. Plus, we also teach anything in the discipline. So if you have your PhD in math, you're expected to teach all the undergraduate courses. So you can't come in there and say, I'm not teaching X. Like, if you say that in your interview, they're not going to hire you. You're expected to be able to teach differential equations, numerical analysis, this class, topology, no matter what's in the undergraduate program, and most things in a master's program. That makes us a little bit different than the other STEM disciplines, right? The bio teacher teaches only like that specialty. typically they don't move around from it. Okay, other questions?